All right, our next set of trigonometric identities are called the Pythagorean identities. Pythagorean identities, okay? Now, we're going to put that in the next box down. So right here, you're going to put the word Pythagorean and underline that, okay? And so now there's only 3 Pythagorean identities, okay? But the 3 identities do include all 6 of the trigonometric functions, okay? Now, the Pythagorean identities, the reason they're called Pythagorean identities is because they're based on the Pythagorean theorem. Now, you may recall the Pythagorean theorem is a squared plus b squared equals c squared and represents the lengths of the 3 sides of a right triangle, which we are dealing with a lot in trigonometry, right? How many times have we seen this, right triangle already in this class? We've got a right triangle. We have one leg is A, another leg is B, and the hypotenuse is C. And when you have a right triangle, there's a relationship among the lengths of these 3 sides such that if you square one of the legs, add to it the square of the second leg, okay, that will be equal to the square of the hypotenuse. A squared plus b squared equals c squared. So in all 3 of these Pythagorean identities, you're going to see something squared plus something else squared is equal to a third thing squared. Now, I'm just going to write down the Pythagorean identities. I'm going to explain the first one briefly. But the second the second and the third Pythagorean identity, I am not going to really explain them. They're going to be a little too detailed. So if you're the first person who doesn't have a future in math, you're going to be good to go. But if you're the kind of person who really loves math, your future is full of math. What I want you to do is you're going to look, if you're in It's Learning or somewhere maybe in the description of this video, you're going to see a link to a Wikipedia image that shows you basically 3 right triangles and gives you an image that explains why each of the 3 Pythagorean identities is what it is. Okay? All right, so let's leave this here and as just sort of a beginning of the Pythagorean identities. All right, the first Pythagorean identity goes like this, and this one is the most important one. You are going to see this over and over and over in your math life for as long as your math life lives, okay? Now, I just remembered I need to explain something to you before I give you these Pythagorean identities. Let's say that I have, 3 times 3. You know that 3 times 3 can be written as 3 squared, correct? So 3 to the power of 2. This is normal. We've learned this probably in 5th grade or maybe 6th grade or something like that. All right. Similarly, when we got into algebra, we learned that x times x is equal to x squared, correct? So anytime we multiply something by itself, we can represent it by just putting a square on it. Well, what we're going to see a bit of here in the next several identities is we're going to see something to the effect of sine of theta times sine of theta. Now, you may be tempted to write this as sine of theta squared, right? But the problem with this is that this can be very easily confused with sine of theta squared, okay, which is not the same thing as sine of theta times sine of theta. This, if you had done it this way, this would actually represent sine of theta times theta, which is not 2 sines, it's just 2 thetas, okay? So now what you could do to represent sine of theta times sine of theta is you can put sine of theta in parentheses and then square the parentheses. Now we have sine of theta times sine of theta. But the math people throughout history have figured out a better way of writing it that makes sense to them. And so I need to introduce you to that way of writing it so that you understand what it means. What we have started doing, or what the math people decided to do, is that when you have sine of theta times sine of theta, what you're going to do is you're going to write sine, and then you're going to square the sine, and then put a theta. So now the way we say sine of theta times sine of theta is we say sine squared of theta, okay? So this means sine of theta times sine of theta. Also, if you see cosine squared of theta, that means cosine of theta times cosine of theta. If you see sine to the 5th power of theta, this means 5 of them. Sine of theta times sine of theta times sine of theta times sine of theta times sine of theta. Okay? And so I'm just telling you that what we started doing is putting the exponent on the trig function word, then putting theta. Okay? All right. So now that you understand that, I can give you the Pythagorean identities. All right. Let's consider a unit circle. Okay, here's the x-axis and the y-axis. And we know, we've learned that if we have this angle right here, this theta angle, that's angle theta, and we have this point up here, we know that the point there is the x and y coordinates are cosine of theta, comma sine of theta, right? And we know, because it's a unit circle, we know that the hypotenuse has a length of 1, correct? Hypotenuse of 1. And if we create a right triangle here, right, we know that the x-coordinate is out to this point right here. So this is the x-coordinate, and the y-coordinate is the height, right? X is the width, y is the height. Okay, so that means x comma y. So what we're basically understanding here is that x is cosine and y is sine. But if we zoom in here, okay, there's the circle. Here's this point. If we zoom in here, and this is angle theta, okay, we know that the right triangle created by this angle theta, since this is x, but it's also cosine, we can say that cosine of theta is actually the length of one of the legs of the right triangle. And we can say that sine of theta is also one of the legs of the right triangle. It's the height. So we have a right triangle with a hypotenuse of 1, because the radius of the unit circle is 1. We have a hypotenuse of 1. We have a height of sine and a base of cosine. And so basically cosine becomes B, right here, one of the legs. Sine becomes A, one of the legs. And the hypotenuse 1 becomes C, right? So if we now plug sine in for A and cosine in for B and 1 in for C, this is what we get. We get the first Pythagorean identity. We get sine of theta times sine of theta, right? It's squared, so it's one of them times another, which becomes sine squared of theta plus cosine of theta is one of the other legs. We're calling it B, so we're going to replace B with cosine of theta. So cosine of theta times cosine of theta becomes cosine squared of theta equals 1 squared, right? The hypotenuse is 1, so 1 is C, so 1 times 1. Well, what is 1 times 1? It's 1. So sine of squared of theta plus cosine squared of theta is equal to 1. And this is your first Pythagorean identity. This is probably one of the most used trig identities in the math universe, okay? And so this is one that we have to memorize. It's so important that I'm actually going to go ahead and put it up here. I'm going to write sine squared, of theta. Sine squared of theta plus cosine squared of theta is equal to 1, okay? That's your first trigonometric identity. All right, the other two I'm just going to write out. I'm not going to explain them. If you're the math person with a future in math, go to that link for Wikipedia and look up the triangle. You'll see that the hypotenuse is one of the functions, one of the sides is 1, or legs is 1, and the other leg is another trig function. And so our second one goes like this. Tangent squared of theta plus 1 is equal to secant squared of theta. And this is a situation where secant of theta is a hypotenuse, 1 is one of the legs, and tangent is the other leg. Okay? And then our last trigonometric function follows the same pattern as this one. It's the cofunctions that go with each of these. So cotangent squared of theta plus 1 is equal to cosecant squared of theta, okay? And that's it for Pythagorean identities. These three, you'll put them in this box right here. It's only 3 of them. And again, what I would do is I would just keep writing all 3 of them over and over and over again until you can memorize them, until you can write them out without looking, okay? In fact, what you may want to do is go back and now write out all the basic ones without looking and the 3 Pythagorean ones without looking, and you'll be building your memory. You'll be telling your brain, hey, these are really important. Don't let them go. You know, put them in the long-term memory, not just in the short-term memory, okay? All right, so that's it for the Pythagorean identities. In the next segment, we're going to move on to what are called the cofunction identities.